The year was 1995. An airplane was getting ready to take off in Anchorage, Alaska. The flight crew sat short of the runway until cleared by air traffic controllers to take off due to a departing C-130 aircraft. 2 minutes later, the airplane rolled down the runway at liftoff and ingested numerous birds in the number 1 and number 2 engines, which were on the left wing, resulting in a catastrophic failure in number 2 and installs number 1 engine. Due to the severe lack of thrust on one wing, the airplane performed a shallow climbing left turn until the aircraft impacted the hill, crashing and killing 24 people on board, according to safetycrusader.com. My name is Jason, and today I'm going to talk to you how a turbofan engine works by discussing basic theories behind engines, engine operation, and how do these affect airplanes in flight. First, let's talk about basic scientific principle relating to aircraft engines. Basic scientific principle behind jet propulsion. Newton's third law of motion. Boyle's law. Newton's third law states for every action there's an equal and opposite reaction. So the airplane is propelled forward due to the force of the air being pushed through the jet engine at a higher speed than the air entering it. Similar to this, how this balloon is reacting here. The air coming out of it is forcing it upwards or forward. Boyle's law states that there's a relationship between a fixed amount of air pressure and volume. When air is squeezed into a smaller volume, it compresses and its pressure is increased proportionally. In our instance, a turbofan engine is superheated pressurized air mixed with jet fuel and ignited. So now we talked a little bit about the theory behind engines, jet engines that is. Let's look at engine operation. So engine components. Without engine components in an aircraft, it would not work. An easy acronym we use is for turbofan is suck, squeeze, bang, and blow. The suck represents the intake, which draws air into it. Say the TF-33, for example, in the aircraft I fly on, draws air into the engine and exhausts about 55% overboard around the fans. So the engine, you have first stage, large diameter fans. A lot of air is exhausted overboard, which creates about 55% of our thrust before it enters the compressor section. The squeeze section of the engine consists of low pressure and high pressure compressors that draw air into it and compress it, which increases by as much as 40 times, and temperature will rise dramatically, stated by geovation.com. Bang represents the combustion chamber, where fuel injectors mix jet fuel into the air and it's ignited, which then sustains a continuous flame and blowing expanding gases outward towards the rear of the airplane. Blow represents the turbofan that drives the compressors, the turbines, that drive the compressors due to the energy exerted from the combustion. The turbines are connected to the compressor section through a common shaft that actually spins. So as the turbines spin after the combusted air leaves, as it spins, it drives the compressor section up front. So here, I got a little basic example for you. As we talked about, suck, squeeze, bang, and blow. So the air enters here, the fan stages. It's about 55% in our case, exhausted overboard, which creates thrust. Then it enters the low compressor and high compressor stages, where it's compressed down, and then enters the combustion section, which mixes with the jet fuel and ignites, which in turn drives a turbine, which in turn drives a compressor, so it's shaft here, and then exhausts overboard, which creates the other 45% or so thrust. And here we have a depiction of thrust, drag, lift, and weight. So lift overcomes weight, the aircraft's weight. And thrust overcomes the aircraft's drag. So now we've talked a little about engine operation. Let's talk about how aircraft thrust affects aircraft flight operations. Engine thrust keeps the airplane constantly moving. Thrust is an artificial force manipulated by the pilot and generated through engines that act horizontally, parallel to flight path, which opposes drag. So when airspeed accelerates, thrust is greater than drag. Thrust allows an airplane to create lift. Lift opposes weight, as I just showed in that depiction. Although during level cruise, lift equals weight. So now we've covered how thrust affects flight operations. Let's recap on what we covered today. So in conclusion, we've talked about basic scientific principles behind jet propulsion, the key components of successful operation, and how thrust affects aircraft flight operations. So next time you're on a flight to the next destination, remember that large birds can take down aircraft as easy as it's going up. Although not all bird strikes are killer, it's essential to keep an eye out for them.